Today we will start with some more questions on definite integrals, and we will complete this chapter also today. So that in the next class we can go to the next chapter. So let us go to the first question. That is integral of square root of 1 minus cos 2x by 2 dx from minus pi by 2 to pi by 2. We can write this as integral minus pi by 2 to pi by 2 square root of 2 sine square x by 2 dx, or it will be nothing but mod of sine x dx, because sine x is odd function. You can write this as 2 times integral 0 to pi by 2 sine x dx. That means 2 times sine x integral is minus cos x from 0 to pi by 2. So 2 into minus cos pi by 2 minus cos 0. So that will be equal to 2. Let's go to next question. Next question we will take is third question. Integral minus 1 by 2 to 1 by 2 mod of x cos pi x by 2 dx. Again, if you see, x cos pi x by 2 is odd function. So you can write this as 2 integral 0 to 1 by 2. Now you can remove mod when we are writing like this. And so directly you can write x cos pi x by 2 dx. We can take pi x by 2 as u. So pi by 2 dx will be du, or dx will be 2 by pi du. So I will write 2 into 2 by pi integral du cos u. And x can be written as 2u by pi. So this will become 8 by pi square integral u cos u du. You can use integration by parts. So if you take integration by parts, what will you have? Suppose if you have integral x cos dx. This is algebraic, this is trigonometric. So u will be x, dv will be cos x dx. Du is dx and v is sine x. So the answer will be uv, x sine x minus integral v du sine x dx. So x sine x minus cos x, or x sine x plus cos x. So I can write here u sine u plus cos u. But then u I can write it as pi x by 2 sine pi x by 2 plus cos pi x by 2. The bounds are 0 to 1 by 2. So I can write this as 8 by pi square. I have to put 1 by 2 for x. So pi by 4 sine pi by 4. Pi by 4 sine pi by 4 plus cos pi by 4. And then minus 0 sine 0. Because the lower bound is 0. So 0 sine 0 plus cos 0. So this will be 8 by pi square. Pi by 4 into 1 by root 2 plus 1 by root 2 minus 1. So I can take 8 by pi square into pi by 4 root 2 plus 1 by root 2 minus 1. Common denominator, if I take 8 pi square. So pi square is anyhow there. Then you will have 8 into 2 pi plus 4 root 2 minus 8. So 8 and 8 will cancel. You have pi root 2 plus 4 root 2 minus 8 by pi square. That's the final answer. Next, we will go to question number 4. Integral dx by e power x plus e power minus x 0 to 1. So first of all, you have to write this as integral 0 to 1 dx by e power x plus 1 by e power x. That is 0 to 1 e power x dx by e power x whole square plus 1. You can take e power x as u. E power x dx will be du. So this integral will become du by u square plus 1. That is tan inverse u, or it is tan inverse e power x from 0 to 1. So you will have tan inverse e minus tan inverse 1. Or you can write tan inverse e minus 1 by 1 plus e using the tan inverse formula. And because that is there in the options. Next is question number 5. Integral minus pi by 3 to pi by 3 sine x sine x by cos square x dx. Okay. So to do this question, first of all, x sine x by cos square x is odd function. So you can write it as 2 into 0 to pi by 3 x sine x by cos x into cos x dx. Or this will be 2 into 0 to pi by 3 x secant x tan x dx. You can go for integration by parts. You can take u as x and dv as secant x tan x dx. So du will be dx and v will be secant x. That means it can be written as 2 into uv x secant x minus integral v du secant x dx. So this can be written as x secant x minus log of secant x plus tan x. Put the boundaries 0 to pi by 2. When you put pi by 2, secant pi by 2 is undefined. 0 to pi by 3, not pi by 2 it is. Pi by 3. So pi by 3, secant pi by 3 is 2. Minus log, secant pi by 3 is 2. Tan pi by 3 is root 3. And of course 0 will give you 0 on the whole. Finally, it will become 0. So 2 into 2 pi by 3 minus log 2 plus root 3 can be written as tan 75 degrees or tan 5 pi by 12, because 2 plus root 3 is the value of tan 75 degrees. Let's go to question number 6. I is integral 0 to pi by 2 sine 2x by 1 plus 4 cos square x dx. So we will go for substitution here. We will take cos square x as u. 2 cos x into minus sine x dx will be du, or minus sine 2x dx will be du. Sine 2x dx is minus du. So I becomes minus du by 1 plus 4u, which will be minus log of 1 plus 4u, that is 4 cos square x by 4. And then you will put 0 to pi by 2. So when you put pi by 2, you will get 0. So minus of minus log cos 0 is 1. So we will have log of 5 by 4. So final answer is log of 5 by 4. You can keep this answer as it is. Question number 7. Integral pi by 6 to pi by 4, 1 by root of cos x sine cube x dx. This we have to find. So for this, you can write, you can change it, and somehow you will write like this: pi by 6, pi by 4. Numerator 1 you divide by cos square x. Denominator you divide by cos power 4x, because it is inside the root. So 1 cos will cancel. And so you will have pi by 6 to pi by 4 secant square x by root of tan cube x dx. So we can use u substitution. U equal to tan x, du equal to secant square x dx. So in numerator, pi by 6 to pi by 4, you can write du, and down the denominator, u power 3 by 2 will become u power minus 3 by 2. So when you take integral, you will have minus 1 by 2 and minus 2. Or You can write minus 2 by root of tan x. Put pi by 6 to pi by 4. So when you put pi by 4, you will have minus 2 by 1. Minus of minus 2 plus 2 by root of tan pi by 6. It's 1 by root 3. You'll have 1 by root 3 like this. So taking minus 2 out, you will have 1 minus 2 into, here you will have, actually this can be written as 1 by 3 power 1 by 4 in denominator. So it will become 2 into 3 power 1 by 4. You can leave the answer here. Question number 8. Question number 8 is integral 0 to 1 8 log of 1 plus x by 1 plus x square dx. So we will put x equal to tan theta here. Dx will be secant square theta d theta. So you will have integral 8 log of 1 plus tan theta by 1 plus tan square theta into secant square theta d theta. Secant square and secant square you can cancel. So left is 8 into integral log of 1 plus tan theta d theta, which you can write it as, I will change the bounds. When x is 1, if x is 1, theta will be pi by 4. If x is 0, theta will be 0. So I will take the bounds 0 to pi by 4. According to one of the properties of integrals, you can write this as integral 0 to pi by 4 will be same, but you can write log of 1 plus tan pi by 4 minus theta d theta. So that will be 8 integral 0 to pi by 4 log of 1 plus 1 minus tan theta by 1 plus tan theta d theta. That's the formula. So it becomes 8 integral 0 to pi by 4 log of 1 plus tan theta plus 1 minus tan theta by 1 plus tan theta d theta. Or it is 8 integral 0 to pi by 4 log of 2 by 1 plus tan theta d theta. Actually, in the beginning we started. What are we doing? If you see, we are finding the integral of 8 log 1 plus tan theta. I can take this as I. So what we got here is 8 integral 0 to pi by 4 log of 2 d theta minus 8 integral 0 to pi by 4 log of 1 plus tan theta d theta. So this is already I here. This is also I. So it becomes 2I equal to 8 into 0 to pi by 4 log of 2 d theta. Or I equal to, this is 2I. So I will be equal to 4. Integral will give you log 2 into theta, in which you will be plugging pi 0 to pi by 4. 0 anyways gives you 0. So when you put pi by 4, you will have pi log 2. That will be the answer. We can go to the next question. That is question number 10. I equal to integral 0 to pi by 2 cos x dx by 1 plus sin x into 2 plus sin x. We have to find what this is equal to. Okay, so we will do the next question, that is question number 10. In this, we will take sin x as u. So cos x dx will be du. So the integral I becomes integral du by 1 plus u into 2 plus u. So actually here partial fractions has to be used. If you have 1 by 1 plus x into 2 plus x, you will separate it into two fractions. First fraction's denominator is 1 plus x. Second fraction's denominator is 2 plus x. The numerators we don't know, a and b. So the numerator 1 can be written as a into 2 plus x plus b into 1 plus x. If you put x as minus 2, you will have 1 equal to minus b or b equal to minus 1. If you put x as minus 1, you will have 1 equal to a or a equal to 1. That means the integral can be written as 1 by 1 plus u minus 1 by 2 plus u du. It will be log of 1 plus u minus log of 2 plus u, or log of 1 plus sine x minus log of 2 plus sine x. You will put 0 to pi by 2. When it is pi by 2, you will have log 2 minus log 3. And when it is 0, you will have 0 minus log 2. So that will be 2 log 2 minus log 3, or log 4 minus log 3, or log 4 by 3 would be the answer. Next, we can go to question number 11. Or we will take question number 12. 13. Integral 0 to infinity x tan inverse x by 1 plus x square whole square dx. So this is having infinity, so slightly it will be different. So what we will do is we will put tan inverse x equal to u. So 1 by 1 plus x squared dx will be du. So I can write x as tan u and tan inverse x as u. 1 by 1 plus x square dx. so that I can write 1 plus x square, 1x square as tan square u. Whereas the other one with dx, I can write it as du. So that means it will be u tan u by secant square u du. Or you can write integral u sine u by cos u into cos square u. 1 cos u will cancel. So you can write this as 1 by 2 integral u sine 2u du. Here you can use integration by parts. If you have x sine 2x dx, how will you integrate? You will take as x and dv as sine 2x dx. So du will be dx and v will be minus cos 2x by 2. So the integral of this will be uv, that is minus u cos 2u by 2. Then minus, which will become plus 1 by 2 integral cos 2u du, using integration by parts. So this will be minus 1 by, I'll take just 1 by 4 outside, not minus, but just 1 by 4. That would be easier. If I take 1 by 4, I will have minus u cos 2u plus sine 2u by 2. After integral, I will have this. So I can put u back as tan inverse x minus tan inverse x. And what will be cos 2u? I will write cos 2 tan inverse x plus sine 2 tan inverse x by 2. The boundaries are 0 to infinity. So first when I put infinity, it will be pi by 2. Tan inverse infinity is pi by 2. So minus pi by 2 cos 2 pi by 2 plus sine 2 pi by 2 by 2. Of course, 0 will make it 0 everywhere. So that will be 1 by 4 into cos pi is minus 1. So pi by 2 and the other one will become 0. That means pi by 8 would be the answer. Next is question number 14. We will skip. We will go to 18. Integral 0 to sine square x sine inverse root t dt plus integral 0 to cos square x cos inverse root t dt. This is what we have to find. So we will put sine square in the integral everywhere. Sine square we have to take. And we have to put sine square y as u. Or sine square y can be taken for t. So 2 sine y cos y dy equal to dt. So what happens is,
I can write this as sine 2y dy equal to dt. The first integral 0 to sine square x becomes sine inverse root of t, that is sine square y. Dt is sine 2y dy plus. In the same way, for the second integral, I'll put cos square y equal to t. Or instead of taking the same variable, cos square u. So 2 cos u minus sine u du equal to dt. Or minus sine 2u du equal to dt. So here I will have 0 to cos square x, cos inverse root of cos square u, minus will come out, and I can write sine 2u du for dt. This will be 0 to sine square x, sine inverse of sine y, and sine 2y dy, minus integral 0 to cos square x, cos inverse of cos u, and sine 2u du. So 0 to sine square x you have y sine 2y dy. And here 0 to cos square x there is u sine 2u du. So here we have to follow integration by parts for x sine 2x dx. Like x you will take as u, and dv will be sine 2x dx. So du is dx and v is minus cos 2x by 2. So that integral we can use it here. For the first one, you will have in terms of y minus y cos 2y by 2 plus 1 by 2 integral cos 2y dy. The bounds are, later on we will see, 0 to sine square x I will write. Here, when I take integral, I will have minus u cos 2u by 2 plus 1 by 2 integral cos 2u du. So when I find the integral, minus y cos 2y by 2 plus sine 2y by 4. Bounds are 0 to sine square x, minus u cos 2u by 2 plus sine 2u by 4. Bounds are 0 to cos square x. Now wherever I have y, I will putting t in terms of t is very difficult. So when t is, I can change the bounds. When t is sine square x, then I can say y will be equal to x. But when t is 0, y will be equal to 0. So I can put the bounds as 0 to x. To make it simple, here itself for y I will change the bounds 0 to x. Similarly for cos, when t is cos square x, u will be equal to x, and when t is 0, u will be equal to pi by 2. So you have pi by 2 to x, the bounds. Directly I will put x. So minus x cos 2x by 2, the first, plus sine 2x by 4, plus sine 2x by 4. When I put 0, everything will become 0 because of y0 and sine 0. Then minus, now I will put x. So minus x cos 2x by 2. And sine plus sine 2x by 4. But when I put minus pi by 2, now I have to put minus pi by 2. So it will be minus pi by 2, but cos pi will make it minus. So pi by 2 by 2, pi by 4 you will have. Then when you put pi by 2, it will become 0 anyways for sine. So this is what you are going to have. So this and this will cancel. This and this will cancel. Left of answer will be pi by 4. That's the final answer. You can leave your answer here. We'll go to the next question. Integral log 2, this is 19th question. Integral log 2 to x dy by root of e power y minus 1 is pi by 6. Then x equal to you have to find. So for this question, I will take e power y minus 1 as u square. So e power y dy equal to 2u du. Or I will write integral dy. I can write 2u by d 2u du by e power y, but e power y I have to write it as u square plus 1. So dy I will write 2u du by u square plus 1. Whereas another u will be there in the denominator. So this u and this u will cancel. Then you have 2 tan inverse u equal to pi by 6, or 2 tan inverse root of e power y minus 1. The bounds are log 2 to x equal to pi by 6. So when you put x, 2 tan inverse e power x minus 1 minus 2 tan inverse root of e power log 2. What will be e power log 2? It will be 2 minus 1 equal to pi by 6. So 2 tan inverse root of e power x minus 1 minus 2 tan inverse 1 is pi by 4. So you'll have pi by 2 equal to pi by 6. Then 2 tan inverse root of e power x minus 1 is pi by 6 plus pi by 2. 2 tan inverse root of e power x minus 1 is, what is pi by 6 plus pi by 2? Pi plus 3 pi, 4 pi by 6, or 2 2s, 2 3s. 2 and 2 cancels. So tan inverse root of e power x minus 1 is just pi by 3. Root of e power x minus 1 is tan pi by 3, that is root 3. E power x minus 1 is 3. E power x is 4, or x equal to log 4. This is how you can find the value of x. We can go to the next question, that is question number 20. Integral 0 to 2 mod of cos pi t by 6 dt. So, if you take 0 to 1, if t is 0 to 1, cos pi t by 6 will be positive. It is actually 2. So pi t by 2 is positive. Whereas if you take from 1 to 2, cos pi t by 2 will be negative, because this will be in the first quadrant, this will be in the second quadrant. So you can write 0 to 2 cos pi t by 2 dt minus 0 to 1 we will write here, and 1 to 2 cos pi t by 2 dt. So when you take integral, you will have sine pi t by 2 into 2 by pi. Put the boundary 0 to 1. Here 2 by pi sine pi t by 2, boundaries are 1 to 2. So when you put 1, you will have 2 by pi into sine pi by 2, that is 1, otherwise 0. Then minus, when you put 2, you will get 0. But when you put 1, you will get minus 2 by pi. So total it will be 4 by pi. The answer will be 4 by pi. We can go to the next question after question number 20. The next question we will take is integral 0 to 1 by 2 dx by root of 1 minus x power 2n. This is question number 21. So how to proceed with this is, we know that root of 1 minus x power 2n will be greater than or equal to square root of 1 minus x square and less than or equal to 1. That's why integral of dx by square root of 1 minus x power 2n from 0 to 1 by 2 will be greater than or equal to integral dx by square root of 1 minus x square 0 to 1 by 2 and less than or equal to integral dx from 0 to 1 by 2. Actually, when you take reciprocal, the signs also will change. So boundaries of x 0 to 1 by 2 will be less than or equal to integral 0 to 1 by 2 dx by square root of 1 minus x power 2n, which will be in turn less than or equal to sine inverse x 0 to 1 by 2. Here when you put 1 by 2, you will have this. This part you can write as it is. You need not find anything. Here, sine inverse 1 by 2, which will be pi by 6. So this would be the answer. You can leave the answer here. Next is question number 22. Integral minus 4 to minus 5 e power x plus 5 whole square dx plus 3, then plus integral 1 by 3 to 2 by 3 e power 9 into x minus 2 by 3 whole square dx. This is what we have to find. So what I will do is I will put x as minus u minus 4. X is minus u minus 4. And in the second one, x I will put v by, okay, I will use u only, no problem. If there are too many variables, you may get confused. But if it's okay for you, we will use v. So x I will put v by 3 plus 1 by 3. That means dx will be minus du. And here dx will be 1 by 3 dv. So the integral becomes e power x plus 5 minus u, 5 minus 1, so 1 whole square. Dx will be minus du. So this is u. Actually, this 3 has to be here. So this minus can be brought here. E power minus u plus 1 whole square du will be there. Or you can write minus u e power 1 minus u whole square du. The final one. And here what will happen? You will have integral e power 9 into x is v by 3 plus 1 by 3. So v by 3 minus 1 by 3 whole square. Dx is 1 by 3 dv. So you'll have 1 by 3 dv. So this will become 1 integral e power 9 and 9 will cancel, v minus 1 whole square dv. I can write 1 minus, if I use the same variable here also u, instead of v, if I use u only. So what I will get here is minus integral e power u minus 1 whole square du. And here plus integral e power u minus 1 whole square du, which will be equal to 0. The final answer I can take 0. We will go to question number, next question. 23. Integral a to a plus pi by 2 sine power 4x plus cos power 4x dx. So if you take the function sine power 4x plus cos power 4x, its period is pi by 2. That's why you can write this as integral a to pi by 2 sine power 4x plus cos power 4x dx. Or this you can write as 2 times 0 to pi by 2 sine power 4x dx. So 2 into, start with 3 by 4, then 1 by 2, and then pi by 2. So 3 pi by 8 would be the answer. We can go to the next question. We will go through some tricky questions like 27th. Integral 1 to 2 f of g of x whole inverse into f prime of g of x into g prime of x. G of 1 equal to g of 2 is given. You have to find what this will be equal to. It's looking difficult, but it is very easy because these all are tricky questions. So in this question, what we will do is we will put g of x as u. So g prime of x dx will be du. Or you can just look at it and say, if instead of two substitutions, if we use only one substitution, instead of 2 times substituting, what I will do is I will take f of g of x as u. So what will happen? F prime of g of x into g prime of x dx will be d. So I can write this as 1 by u and this as du. That means I have log of u, log of f of g of x from 1 to 2. So when I put 2, I have log of f of g of 2 minus log of f of g of 1. But because g of 1 and g of 2 are same, instead of g of 1, I can write g of 2 only, which makes it 0. See, it's very easy. With one substitution, you can do it quickly. Like this, there are many more tricky questions. For example, the 15th question also was tricky like this. F of 0 is equal to f prime of 1. It is equal to 1. If integral of t into f double prime of t dt from 0 to 1 is 0, then you have to find the value of f of 1. So all such tricky questions, actually, they are very easy to answer. First, we will take this integral and we will use integration by parts. Like u, I will take it as t. dv, I will take it as f prime of f double prime of t dt. So du will be dt and v will be f prime of t. So I have t into f prime of t minus integral f prime of t dt. So this becomes t into f prime of t minus f of t, which is equal to 0. If you put t as 0, you will have this as 0. Isn't it? Now you have to put the boundaries. Boundaries are 0 to 1. When you put 1, you'll have f prime of 1 minus f of 1. When you put 0, the first one will become 0 minus f of 0, which is equal to 0. So f prime of 1 is 1. F of 1 we don't know. Plus f of 0 is also 1, equal to 0. So f of 1 will be equal to 2. Like this, some questions you can learn. So I think we are done with enough number of questions from definite integrals. Next class, we will learn about a new topic. We'll end this class.